Okay, so now we're going to look at an example here. This example is of ginkgo biloba, which is a kind of a trendy health additive for a while. I don't know if it still is. Anyway, so this is kind of a silly example that I made up, but I think it illustrates the purpose. So you have this drug study, and we're trying to measure the benefits, health benefits of ginkgo. All right, and here's how we're going to design the study. Each participant in the study is given a pill to take daily, and the resting heart rate is measured weekly. So the resting heart rate is some kind of measure of health. Okay, there are two different pills. One pill is a dosage of ginkgo, and one is a sugar pill that looks and tastes exactly like ginkgo. So the people in the study can't tell them apart. Okay, so why would we set it up this way? Well, now this is the idea is that when you take a drug, sometimes you respond to the drug, but oftentimes you actually respond not to the drug, but to the perception of treatment. Okay, it's the way that you're treated while you're doing while you're taking the drug. So so that's what we're trying to do. We're trying to ferret out the differences between the actual effect of medication and chemical interaction, and the effect of everything else that goes on when you're prescribed something. Okay, this false treatment, so people think they're getting a treatment, but they're really not, is known as a placebo. Okay. In this case, the placebo acts as a control group. We could have a separate control group, but in this particular case, in this particular experiment, there's a placebo group, and that acts as a control for the individuals. Now, would it work the same way if we told the participants who was getting ginkgo and who was getting a sugar pill? Now, it probably wouldn't, because then the people who were getting the sugar pill would feel like they're not really getting treatment. Okay, so they may the goal here is to decide whether or not the notion of getting treatment is somehow confounded with the actual chemical reactions. Okay. In order for a placebo to work, the participants in the study have to be what we call blinded. Okay, and there's actually a movement now to call it the masked rather than blinded, but in the AP statistics terminology, we use the term blinded. Okay. This is referred to as a single blind experiment because in this case, the people taking the pills don't know what pill they're getting. Okay, that's the single blind. Okay, so the question is, what if we didn't tell the doctors who were prescribing the medication either? Okay, we would refer that to that as a double blind experiment. And the advantage there is that if the doctors don't know, then the way they treat their patients, the patients who are getting an active treatment versus a false treatment, is going to be the same. Okay, so a situation like this would be a good candidate for a matched pairs experiment. Okay, and we'll take a look at a great Lipitor ad in class. In this case, there are only two treatments. Okay, there's in this case, a placebo and an active treatment. Okay. And the idea is that we could reasonably pair up each of the subjects according to some kind of biological characteristic, and give so every pair would be paired up, and I'd flip a coin to decide who would get the active treatment and who would get the placebo. All right. So a couple more definitions we need before we move on and really do some work with this. Definition one is completely randomized design. In this case, every individual has the same chance of receiving each treatment. This is kind of analogous in some ways to the simple random sample in sample design. Okay, a completely randomized design means that a bunch of people come into a room and every person has the exact same chance of receiving every treatment. Okay, a randomized block design is just a fancy name for blocking. Okay, every group, every block. Okay, we block on a variable. We blocked on age. Okay, we could block on something else for the Big Mac experiment. Within each block, there is randomization. So randomized block design is you separate into blocks, and then within those blocks, you randomize the treatments. Okay. So the last term I think we need to really focus on is something called statistically significant. And so the question is, when we do these experiments, what do we hope to find? Well, there's really two things. Okay. We hope to find some significant difference between the response to treatments. Okay. Those who got the placebo, those who didn't. We want to see that they responded significantly different, okay? Or we hope to find some significant difference between what we know is true and what we find on our data. Okay, so we want to upend the status quo. Okay, so we're either looking for a difference in responses, or we're looking for some kind of rejection of what we know as a society is true. And that's what it means to be statistically significant. Is big enough so that that difference wasn't due to chance. Okay. All right, and that's it for today. Tune in next time.